Hi everyone, I'm going to review some factoring techniques in section 5.7 in your book. And then we're going to look at some special factorization. We're going to factor sum and difference of cubes. We'll look at perfect square trinomials and differences of squares. Okay, so here's a review of factoring and what it is. So we want to remember that we have here a term, okay, which is a number or the product of a number and one or more variables raised to some powers. And the number in front of it is the numerical coefficient. We just call it the coefficient. And then a term that is only a number, like 2/3, is called a constant. When you take these terms and add and subtract them, they're called polynomials. When you have one term, it's called a monomial. So here's some examples of monomials. When you have two terms, you have a binomial, right? The prefix bi is 2. And then trinomial, the prefix tri means 3. So there's 3 terms. Every term has a degree, and it's the sum of the exponents on the variables in each term. So if I wanted the degree of this monomial, this term here, I would add 5, and then the degree of y is 1. So 5 plus 1 is 6. The degree of 7xz would be 2, because I would have a 1 and a 1. 1 plus 1 is 2. Every polynomial also has a degree, so it's the largest degree of its terms. So if I was looking at this example again, which is a binomial, it's got 2 terms, you have the degree of 4x to the 5th y is 6, and the degree of 7xz is 2. So we take the higher one. So the degree of the whole polynomial would be 6. Okay, so we can add, subtract, multiply, and divide polynomials. In this beginning part of the lesson, we're going to be multiplying the polynomials. So if I take a look at letter A, we have 2x to the 3rd times 5x to the 6th. So I can use some properties of real numbers to multiply. When we talk about properties of real numbers, we're referring to properties like the commutative property and the associative property. Okay, we also look at the distributive property. The commutative property, though, allows me to move the numbers of the terms around. So I know I need to multiply 2 times 5, so I can put those together. 2 times 5. And then I need to multiply x to the 3rd times x to the 6th, so I'm going to put those together. And multiplying 2 times 5 just gives me 10. And when I multiply like bases together, so x is a base, I would add the exponents. So I would get 3 plus 6, which gives me 9. So my final answer would be 10x to the 9th. In letter B, I would need to use the distributive property because I have a product times an expression in parentheses. So I have 2x times 5x and 2x times -4. So 2 times 5 gives me 10, and x times x gives me x squared, right? 1 plus 1. And then I have 2x times -4. So 2 times -4 is -8, and then x. So my final answer is 10x squared minus 8x. Those are not like terms, so I can't combine them. I would just leave my answer like that. Okay, in letter C, I'm going to distribute the -3x squared to what's in the parentheses. So I have -3 times 4, which gives me -12. And then x squared times x squared gives me x to the 4th. And then I've got -3 times -6, which is positive 18. X squared times x gives me x cubed. And then I have -3 times 1, which is -3 x squared. And again, those are not like terms. They don't have the same variable, same exponent, so I would just leave my answer like that. Now letter D, I have a binomial times a binomial. And whenever I have that, I can use a process called FOIL, which stands for first, outer, inner, and last. So if I multiply the first terms together, like x times x times x we know gives us x squared. Then if I multiply the outer terms, which would be the x and the 5, x times 5 gives me 5x. And then you have your inner terms, which would be 3 times x, which just gives me 3x. And then my last terms, which would be 3 times 5, which is 15. Okay, and if you look at this expression, we can simplify. 5x and 3x are like terms. So my final answer, I would get 8x squared plus 8x plus 15. Okay, so in letter A, I have a monomial. In letter B and in letter B, I have a binomial. I have 2 terms. And then in letter C and letter D, I have a trinomial. I have 3 terms, 1, 2, 3, and then 1, 2, and 3. So now what we're going to focus on is what happens if you were given the solution to the last problem, x squared plus 8x plus 15, and I want you to find the original factors. So in other words, how would you know that x plus 3 times x plus 5 would give you x squared plus 8x plus 15 if you start with this? So what we're going to use is a process called factoring, which is the reverse process of multiplying. And what we're going to do is write the polynomial as a product, okay? Now, there's several ways to factor. So here's a little flow chart that you can use to determine which method to use. We're going to cover all of these methods in this lesson. So no matter what, you always want to start with factoring out a greatest common factor, okay? No matter what the technique is that you're going to use, always look for the GCF. If there's 2 terms, you can try looking to see if it's a difference of squares, a sum of cubes, or a difference of cubes. If there's 3 terms, which is the most common, you can check to see if it's a perfect square trinomial, factor by guessing and checking, or factor using the AC method. And if it's 4 terms, more than likely you're going to use factoring by grouping. But again, always, your first step should always be to look for a greatest common factor. So let's review really quick how to factor out the greatest common factor. So if I take the binomial here, 8x squared plus 4, and I want to factor using the greatest common factor, I want to find the greatest number that divides into both of all of the terms, right? So my terms here are 8x squared and 4. So what do they both have in common? What can divide into both of them? Well, I know 4 goes into 8 and 4 goes into 4. And if I look at my terms, I have an x squared here, but I don't have any x's there. So there's no x's in common. The only number in common that I can take out is a 4. So 4 is my greatest common factor. So to factor this, I'm looking for like what times what will give me 8x squared plus 4. All you're going to do is divide each term by the greatest common factor. And if I do that, 8 divided by 4 gives me 2, and then you have an x squared attached to it. And 4 divided by 4 gives me 1. Okay, you can also look at it like this. 4 times what will give you 8x squared? 4 times 2x squared. And 4 times what gives you 4? 4 times 1. Okay, these are the factors. Factors are just things you multiply to give you the product, right? So here, when we do factoring, The product is actually the problem you're starting with. That's your answer. And the factors you're getting, right? That's what multiplies to give you the product. So 4 is a factor, and 2x squared plus 1 is also a factor. So when you multiply factors together, you get a product. It's the reverse of what we did here. So here are your factors. This is your product. Okay, so now we're starting with the product and going backwards to get the factors. It's a very important thing for you to be able to do because it's used in all math. Okay, in letter B, we have a trinomial. So I'm going to look at each term and first look at the numbers. What goes into every single one of those numbers? So 3 goes into 6, 3 goes into 3, and 3 goes into 12. Okay, so I'm going to take a 3 out. And then each of the terms has an x. This one has an x squared. That means it has 2 x's. And this one has an x cubed. That means it's got 3 x's. And then the last one has 4 x's. So for my greatest common factor, how do I know what to take out? Well, I can't take out the most. I can't take out 4 because this only has 2 and that only has 3. And I can't take out 3 because this one doesn't have 3 x's. But all of them have at least 2. So I'm going to take out the lowest exponent. 3x squared would be my greatest common factor. They all have at least 2 x's or x squared in common to each term. So 3x squared is going to be my greatest common factor. So I'm going to pull that out of there. And then to get the leftovers, remember, I'm just going to divide each of these terms by the greatest common factor. So I'm going to divide my numbers. 6 divided by 3 gives me 2. And when I divide like bases, x, remember, is a base, we subtract the exponents. So 2 minus 2 gives us 0, and x to the 0 is just 1. So there's no x's there. The x squareds actually cancel out. And then I've got negative 3 divided by 3, which is negative 1. Okay, I'm going to hold off putting the negative 1 there for a second. And then I've got x cubed divided by x squared. So again, when you divide like bases, you subtract the exponent. So 3 minus 2 gives me 1. So this is just minus x to the first. And then for the last term, I've got 12 divided by 3, which is 4. And x to the fourth divided by x squared, I'm going to subtract the exponents. 4 minus 2 is 2. And there's my final answer. And you can distribute to check it. So 3x squared times 2 gives me 6x squared. 3x squared times negative x is negative 3x cubed. And 3x squared times 4x squared is 12x to the fourth. Okay, for letter C, I'm going to look at each term. Okay, so I have a binomial. I've got 2 terms. And the greatest common factor that goes into 17 and 34 is actually 17. They both have an x, but I have an x cubed and an x to the fourth, so we're going to take out the lowest one, which is just x cubed. And they both have a y squared, so that makes it easy. That's the one that's in common. So I'm going to pull out a y squared. And now I'm going to just divide all of the terms by my greatest common factor. (17 divided by 17, so let's put our GCF first. 17 divided by 17 just turns into 1, right? X cubed divided by x cubed, that cancels. And y squared divided by y squared cancels. So that whole term cancels there, so I would just put a 1. Negative 34 divided by 17 is negative 2. X to the fourth divided by x to the third, remember, subtract the exponents, you get x to the first. And then the y squareds just cancel. So now to check this, you could just distribute. And you would get 17x cubed y squared times 1 just gives us 17x cubed y squared. And 17x cubed y squared times negative 2x. 17 times negative 2 is negative 34. X cubed times x is x to the fourth. Remember, when we multiply like bases, we add exponents. So 3 plus 1 is 4. And then y squared times just 1 is y squared. So you get that expression back again. In my last problem, notice I have an x cubed, an x squared, and an x to the first. We call that descending order because the exponents start out with the greatest and go down to the lowest. Also notice that there's a negative in the front. So typically when there is, we want to factor the negative out with our greatest common factor. So we know we're going to have a negative. And if you look at your numbers, 3, 2, and 5, there's nothing in common to all of them. So we're not going to factor any numbers out. They all have an x. We take out the lowest one, which would just be x. And they also all have a y. So your greatest common factor here is just negative xy. So I'm going to divide each of these terms by negative xy. Remember, it's really just negative 1xy. So negative 3 divided by negative 1 is positive 3. X cubed divided by x is x squared, because remember, we're subtracting exponents, and there's 1's here. And then the y's are going to cancel out. 2 divided by negative 1 is negative 2. X squared divided by x is just x, and the y's cancel. And negative 5 divided by negative 1 is positive 5. And then the x's and the y's cancel. So your final answer is just negative xy times 3x squared minus 2x plus 5. And again, to check it, you would want to distribute. Okay, I'm going to stop the video there, and then I'm going to continue with other factoring techniques in the next video. Please try the check your understanding problems and practice to see if you can factor out to the greatest common factor, because it's a very important tool. We'll be using it in all of the techniques that follow.